his research areas closely with our department subject. And then, of course, Professor Robert Turner has expertise in the artificial intelligence. Today, specifically, Professor Robert Turner would like to share about the thought of computer, real or unreal, and so how the computer can calculate, obviously much better than human beings. So we are now using the most our activity, business activity using computer, right? Like today we're talking about accounting. Used to we use a manual, but with nowadays we use a computer to help our daily operation. Okay. So without further ado, let's welcome Professor Robert Turner. Okay.
Thank you very much. I'm very happy to be here with you, and I want to give you a talk about thoughts of computers. I know you are first class at the university, so my issue is not too heavy to understand because I use a lot of topics we are very familiar with because we all use computers, and I don't want to talk about computers very much. I want to talk about thinking. So everybody of you is thinking, right? Who is not thinking? Nobody, that's very fine. You are not thinking? No, sorry, okay. So, and the question is, and a lot of computer scientists are looking for a system which is able also to think like human beings are thinking. So thoughts, we are very common with thoughts, but in my talk I want to point out 7 points. I want to talk about machines in a very abstract manner, because computers are machines, as you know. I want to talk about acting. Acting has a lot to do with thinking. I will show that. And after that, we have to talk about what is a thought. Everybody has a lot of thoughts, but only a few people are thinking about what are thoughts, and I will give you a short idea about what a very small thought is. The big word information. Information is a very big word. Why? Because there are more than 100 different theories about what we mean when we say information. And especially the computer scientists, they call themselves information experts. They tell us that our computer is processing information, and the question is that true? I will give you an answer to that question, and I think you will be interested in that. So the computer itself is a short issue in point 5 of my speech. And you see this light blue words. There is also a definition of a computer. I call it mental worker. So it's a machine which is able to work mental issues. And the question is, can a computer think? That is a similar question to, has a computer a thought? A thought and thinking is not the same. A thought is that what our thinking processes are using. And you will see computers are a little bit like our brain regarding the thoughts, but not regarding the thinking. And I give you a conclusion after that. So machines, machines are used by humans to improve their life, to make things easier. You use computers as calculation machines to make your homework. A lot of industries using machines, and the human being is a very great inventor of machines, which normally substitute or help us for moving goods. For example, I was sitting 12 hours, 3 hours ago in a machine which brought me 11,000 kilometers from Frankfurt to Taipei. So this machine is great because I don't have to do anything. There is only one person controlling that machine, the pilot, and we are able to produce very interesting machines, moving normally goods or moving persons. So this is one type of a machine. And the humans try always to make machines better than the humans itself. So if you drive a car, you can move from one place to another place with a very high velocity. The speed is much more higher than if you would take your feet. So the machines we are constructing mostly are much better than we are. So cars are faster, cranes can load heavy weights. We never would be able to leverage 1 ton of weight. So all the machines are much better. Thinking about that comes to the question, what about if we build thinking machines which are able to think much better than we do? And this is for sure the future. You all use probably even now large language models, ChatGPT, which is much better able to have an overview of a huge amount of knowledge. You never would have that, even if you learn all your life. So this machine knows more than any human being. So another example of a machine which is much better than we are. So the development of machines is also a very interesting issue. When you think about machines which are able to move goods or items, we have an old machine, the power machine, you know that from movies perhaps, a steam machine that was invented some 100 years ago, and to produce such a heavy machine you need the knowledge and the technology, for example, for steel casting. And it's interesting, steel casting, the knowledge for steel casting is in China 3,000 years old, in Europe only 300 years old. So interesting that this steel casting technology and knowledge is known for hundreds of years and only used the last 400 years to produce tools. And there was one special invention, a machine which is called dynamo, and this machine is producing electricity. Without electricity you wouldn't be able to drive your computer. So electricity is the necessity for computerization. And so we have different technologies, the semiconductor for making small electric devices. We have networks to make digitalization, and this is a kind of development of the machines, especially in the area of computers. And I will show you a very old machine, not so old, 90 years old, the first calculating machine, which was not made of electrical devices, but also made of steel. And the question is, what will happen in the future when we really have a strong artificial intelligence and we wait for this thinking machine, a real thinking machine, not ChatGPT, which is able to give me an answer to a question based on a very high database knowledge or knowledge in a artificial neural network, a machine which is able to think like humans are thinking. When we have that machine, and I'm sure we will have, the question is, what is about the acceptance of that machine? We talk a lot about acceptance, which machine is accepted by human beings and which not. And this is always a discussion. This was a discussion with the steam machine, with the computer. In the 17th, people said, oh, computer will steal my job. So these discussions are very familiar, and we will have this discussion again when there is a real thinking machine. You know that from movies, for example. Who saw the movie iRobot? iRobot is this fiction about a humanoid robot which is able to think and speak like a human being. And I'm sure this machine will be invented sometime. And so you have to define legal issues, what to do with that robot, this robot is killed in that movie, is that legal or not? So we have to discuss that. And in Europe, they discussed the Artificial Intelligence Act. So this is a new law in Europe that every company has to be careful about using artificial intelligence for offering services, especially regarding the personal data of people. So legal issues will lead to, I call it, emancipation. So the machine will be emancipated from human beings. They don't need us anymore if everything is clear ruled. And then we can put that thinking machine into a robot. The technology is already there. We have robots which can move themselves, which can move other things, but they cannot think at the moment. So we need this thinking machine, put it into a robot, and then we have a humanoid machine, which we know from movies. We are not so far away from that. I give you some ideas about that. The word acting is also very familiar with us, to us. But if you think about which different type of acting are possible, we come to 3 basic types. We can make a physical act, we can move things or our body. This is a physical act because we move material. We can distinguish a think act. So thinking is not a physical act. We don't move any particles or any material. Thinking is taking place in our head, nowhere else at the moment. And we can distinguish a speech act. Speech act means I talk to you, and of course I have to move my vocal strings to produce waves in the air so you can hear what I say. So this is a complex acting. Not many species on this planet are able to communicate. Whales are able to communicate, human beings are able to communicate, and then it's getting very rare of animals who are able to speak. And this speech act needs a lot of my brain capacity. So this is a very high developed act. And acting on physical entities only means moving entities, that's all. And acting on mental entities always means thinking, changing information, changing your thoughts. You can then make a distinction between this physical type of work, mental type of work, and you can ask, is that done by a human or is that done by a machine? I call that human machine matrix. And of course, you can, that's me and a friend on the roof of a house. You can work physically if you like that work, or of course you can as a human work mentally, but you can also take a machine which is doing that work. So preparing a roof is not at the moment possible by a machine, so you need human work at the moment, but this is what we want to make easier. And mental work, you are doing a lot of mental work at your studies at the moment. You are busy in listening to me, that is mental work. You try to understand what I say, you try to remember, to save what I'm saying in your memory. This is mental work. And of course, last but not least, the question is, can a machine do mental work? And the machine here, I will explain that a little bit more in detail, was the first machine in the history of mankind which was able to fulfill a complex mental work. So that must be aware if you talk about computers, because computers are doing mental work. I will show that in some minutes. No, I will show that now. One exercise for you. What do you think? mental work for you. I already did it. Who wants to answer?
151.5.
Yes, 151.5 or rest 1. This is not an easy mental work. My daughter, she's 9 years old, she's now able to solve this problem and be able to make this mental work. So when you calculate this simple term, what happens in your mind? You use probably some interims results, right? So if you see this numbers here, 300 for example, probably that was a number in your mind when you did this mental work. And this was the idea of the inventor of the computer, building the first machine which was able to calculate such terms in a universal way. He was aware when we want to solve complex terms, we have to have a memory. And we do that when we don't have a computer, we do that on a paper, right? If you're not able to save too much numbers, then you take a paper and you memorize that on a paper. And that's what he did, constructing the first universal computer in the world in the year of 1937 in Berlin. That is Konrad Zuse. And look at this machine. What is this machine made of? The first computer was made of steel, not made of electronic devices. So this is the proof that you can do mental work by a mechanical machine. Nothing else. That's why computers are machines like other machines too. But of course, if you look at the architecture of that machine, and I already told that, he was the guy who was implementing a memory where he could store 22 numbers. Not much, your computer can store billions of numbers. But this was the first machine with a universal architecture. He could give an input, the term, he could give the input of numbers. He had an algorithmic logical unit to calculate these things, and he had an output device to give the results back to the user. And this is the same what your computer has nowadays. You have a keyboard and you have a display. Of course, much more sophisticated than at those times, but the most important was the memory. And of course, it's unbelievable that this was the first mental work ever done by a machine in the history of humankind. So I'm totally enthusiastic about that, because that was the beginning of giving mental work to machines. And if you look at the power data, the calculation speed was 1 calculation per second. That's nothing compared to your computer or your handy or your watch, which makes millions or billions operations per second. That is the development of this machine, computer. But for me, it's important that you understand computers are always doing mental work. If we wouldn't have computers, we would have to do that by our mind. We cannot give that to another machine, except a computer. That's the task of a computer. And why was that possible, giving a mental task to a machine? That was only possible because these machines uses the binary system or dual system. And this was invented 100 years, more than 400 years before by a mathematician, Gottfried Wilhelm Leibniz. They call him the inventor or the father of informatics, because he defined the dual system. Who was learning the dual system at school? German? No? Russian. Only the Russians learn the dual system at school? German? French. You learn the dual system at school too. In Germany, all pupils have to learn the dual system at school too. So to learn that, you not only can calculate with numbers on the base of 10, because we have 10 fingers, but you can calculate on the number of the base of 2, 0 and 1. And this guy invented this method of calculating plus minus factor division. And this is the beginning, this is the only possibility at the moment to construct a computer which is able to make computational tasks. And out of that computational task, I will show that you can also make higher level mental works, not only calculating. We do that at the moment. I don't use that computer, for example, for calculating. I use it for presentation. Okay? So, not so old, but very interesting for me is that this man found the atomic unit for computing or for digital machines. So this bit, 0 or 1, you cannot divide that. You can divide the number 2 in 1 plus 1, but you cannot divide 0 or 1. This is the atomic unit for calculation, for digital machines. And every digital machine on this planet is using this system, which was invented by this man. And why do I want you to understand that? I want you to understand calculation needs an atomic unit. And philosophers, for more than 2,000 years now, are searching for the atomic unit of thinking. And that is not the bit, like you can imagine. And I will introduce you to my idea or what I found out, what is the atomic unit of thinking. And that's interesting. Okay. And another also astonishing issue is this man, Leibniz, he was inspired by another system. He was inspired doing this dual system. And some of you, if you are from China, know this hexagon, these hexagrams. Who does know this book, I Ching? Probably I pronounce it wrong. Does that anyone? No? You know it?
No, I don't know.
You don't know it. So this is a very old, this is more than 500 or 700 years old. This hexagrams in this book inspired Leibniz because this looks a little bit like a dual system. And this book was for forecasting, not for calculation. But anyway, so astonishing to me is that this German guy knew about a book from China, and he was inspired by these codes here to develop the dual system. So again, you can see how important it is that the science is connected, how important it is that here are Russian, French and other nations in this classroom, because you can exchange experiences. So the Russians and French can explain the Taiwanese students about the dual system, if they want to. If you meet tonight, explain it to them. Okay? So we are at the basic of computer science. We want to switch to our brain, and we want to think about what is thinking and what is a thought. And probably you know, this is the task of philosophers. Philosophers try to find out how we see the world, what is the smallest unit of thinking, and so on and so on. And for that, they postulate for example, from Plato, Aristoteles, rational thinking, logic, nature of human mind. What do you think is logic? We use that word probably every day. If someone tells you about things you already know, you say, oh, that's logic, I know. That's logical. Did you use that word? Yes. Normally we use that without knowing what that means. What is logical?
Standard thinking, like the standard, it's like something that is standard, I guess.
Standards. Yes. Yeah, so standards or rules
Yeah.
are part of logic, yes. I give you an example of a very easy logic. Probably some of you know the term transitivity from the mathematics. Transitivity is a basic logic we use when we orientate, when we talk to other people. And I give you an example. I need 3 items. I take this cup, item 1. I take my phone, item 2. And I take my glasses, item 3. So these are my mobile parts now. And if you look at these 3 items, you see from your perspective, this is right to the phone. Okay? The phone is right to the glasses. And from that you know the cup is also right from the glasses. So this is transitivity. We implicitly use that when we orientate us, when you go through buildings and if you know one room is behind the other room and the next room is behind the other room, you know the third room is also behind the first room. We use that logic very intuitive. But you have to be aware that this is a logic. And in mathematics we use that for the bigger or less, for making numbers in a right order. Okay? 2 is less than 3, 3 is less than 4. That means it's logic that 2 is less than 4 too. Transitivity. But we don't use it with numbers, we use it with a lot of different things when we think and when we make a combination and when we derive new insights out of known things. If I know the position of this compared to each other and this compared to each other, I know the position of the 2 new things. I can derive that with logic. So logic is what our brain is always doing. Right? To explain the family relationships. What is a sister? You use logic. Sister means 2 persons have the same mother and the same father. So if you know there are 2 persons having the same mother and father, you know these are sisters. This is logic. So deriving new information out of known information. That means rational thinking. It's not rational if you say these 2 guys have different parents but they are sisters. That's not rational. That's another logic, not the logic we use. So thinking, we are aware of thinking very easily because we learn that from baby. We learn that right-left thing from baby without realizing that. And now there comes the philosopher who tries to understand the rules of thinking. And this is also interesting for computer scientists because they are able to translate thinking to this machine which is able to fulfill mental work. That is very close together. And that makes my job so interesting because I try to work on these issues. And there is another famous sentence you never should forget. Take care. Nobody should forget that sentence. Cogito ergo sum. Who already know this, the French, the Russian, which country? South Africa. Okay. And which country? Hungary. Okay. Cogito ergo sum is one of the most famous sentences of Romance, and that means I think, therefore I am. And probably you have thought of that sentence. If you hear that it's the first time, you think, what stupid thing is that? Normally you don't understand that immediately. I think, that's why I am. And you can understand that much better if you think about moving and thinking. I introduced my lecture with this intervened two terms, moving and thinking. We need thinking to move, and moving left-right, moving orientation develops our thinking. And when you think about thinking, thinking is obviously the prerequisite for acting. If I lift this bottle, I have to think about this. Not explicitly, but implicitly, there are thoughts in my brain before I start to lift this bottle. So this is another distinction, explicit, implicit thoughts. We have that a lot. But you need thoughts, you need to think before you act, before you go to school or before you go to bathroom. You have to think about what will I do now, what will I do next. And without acting, we definitely cannot be, because acting means moving, and moving is needed for what? The most important two things, eating and reproduction. Could you imagine reproduction without moving? No, not for us. That is for plants. So plants are able to eat, to get nutrition, and to reproduce themselves without moving. They don't have muscles, they don't move, but they are able to reproduce and they are able to eat. They take the water out of the ground, they what is Wurzel? Roots, thank you. They have roots. Of course, the tree is growing, but not moving. And so my idea is, because plants don't need to move, they don't have a brain. You don't need a brain if you don't move. What for should you use your brain if you don't move at all? If you don't speak, speaking is moving, you don't need it. So this is a small proof. This is not scientifical, but this is an idea to give you that motion and thinking is close together. Now come to the next test. I make a lot of tests with you today. I want to hear some words from you. What do you think? We try to understand what is thinking. What do you think when you look at this picture? What thought is flying through your head?
Nature.
Nature. Very good. Other thoughts?
Buildings.
Buildings. Very good. Buildings. Pardon? Mountain. Yes. Mountain. Other thoughts? Pardon? I can understand it's too Taipei. Taipei. Very good. Taipei. Why Taipei? Oh, the 101. So there is also a thought 101 flying through your head. He's a high flyer. A lot of things are flying through his head. But even if you don't tell me the words which were at your brain, I think you had the same ideas, right? So looking at a picture means getting impressions from outside to our brain, and normally we immediately have ideas about things we know. So we recognize this 101 tower, we recognize using that 101 tower that must be Taipei. We had tree, forest, nature. So we are not able to, if we look at a new picture, that's because humans are always curious. We are always curious, and it's not able for you, if you look at a picture, not to think about things you see there. So this was my intention, to create thoughts in your brain. Isn't that fantastic? I can manipulate you. I can make you think about the 101 if I want. If I show you a picture, you start thinking about the 101. So it's totally easy to create thoughts in the brain of a person. And the core question is, what is the smallest possible thought you can have? Similar to the smallest possible unit for number calculation. What do you think? What do you think now? And let it out.
Quarks.
Pardon?
Quarks.
Quarks?
Quarks.
What is quarks?
Like the smallest level. Yeah, like.
Yes, this is in the physics. Yeah, the physics, the smallest. This is in the world of physics, matter and waves. But we are in the world of thinking. That is the difference. So physical world, mental world. What do you think when you looked at the picture? What could be the smallest thought you can have? What do you think?
Humidity.
Pardon?
Humidity.
Humidity. Humidity is a word for a phenomenon, and you are right. Humidity, you cannot think of less than humidity. Humidity, for example. Yes?
We have some more philosophical questions, but what makes a thought small?
Yeah, so the question is, what makes a thought small? So it depends on we are looking for the smallest unit. So a thought, like humidity, you cannot think of less than humidity. And you cannot think of less than the 101 tower. You understand? But I can connect a lot of thoughts to make a bigger thought. I can say humidity is on that picture. So these are more than 3 thoughts. Humidity, picture, where is it? It is on this picture. So this is a bigger thought, a bigger part of information. And we will learn a thought is nothing else than information. And the question is, what is the smallest possible thought? Humidity, 101. And this is a term which comes from the philosophy. You know that term probably, and the computer scientists use that also. The term for this, what is the abstract of the 101 and humidity? Abstraction is also a principle in the logic our brain uses. Who can explain what abstraction is? Make things abstract. We do that thousands of times a day. What do you think is abstraction? No idea?
The background. Like the background.
So it's no, not the background. Abstraction. When we deal with different terms, I give you an example. I try to look at a good example. Not so easy for me too. Why ask a question to you which I cannot answer? Let's take the family. The family is a good example, a good area, because we are very familiar with terms in the family. So we can say a daughter and a son are, what is the common thing when you talk about a daughter and a son? Yes, they are kids. So kid is the abstract of daughter and son. So this is abstraction our brain uses all the time. So we formulate, we have an idea of common characteristics, and this common characteristics, for that we define a new word, child. Child is a new word only for the common characteristic that this is the child of two persons. Could be a boy, could be a girl. If it is a girl, we call it daughter. If it is a boy, we call it son. Logic. And we don't go to school to learn this logic. We don't go to school to learn abstraction. We learn that in the family. We learn that the old people are saying child to me and to my brother and to my sister, and that's how I learn these abstraction terms. So, and the question is, if you use all terms, you know what is the most upper abstract term. What do you think? Everything is an, if I tell it, you will say, oh, of course, I knew it. Everything is an object. Everything is an object. And the philosopher says everything is an entity. Did you hear the term entity in your life? Yeah? In which situation did you hear this?
Living entity.
Pardon?
A living entity.
A living entity. Okay, so it's a distinction between living entities and non-living entities. Yes. So an entity is the most abstract term. The word, it's only a word, it's only a name for the most abstract thought we can have. That's it. It's because we are thinking about these living entities or not living entities. We use that for communicating, and we use that for organizing all the things which we see in our life. Otherwise, we always would have to define a new name for every item, for every object we observe. I don't give this table a name. I say it's a table. This is a table, this is a table. But when you are the responsible maintenance person, probably you give every table a number to identify the table. Okay? So table is an abstraction of an item, and the most abstract item is entity. The most abstract name or thought, at the end, it's a thought, nothing else. And we give the name entity for that thought. So, I hope you understood that one entity and not the quarks are the, regarding our thinking, regarding our mental world, is one entity, one thing, one object. We cannot think of less than humidity. What should that be? Of course, we can think of single water drops, which makes the humidity, but then these are the next thoughts. We didn't divide the term humidity. Impossible. So, and this is spectacular. You now are a few persons on this planet who are aware what is the smallest possible thought. And that's important to implement that in a computer. That's it. Who didn't understand that? Everybody understands? Okay, at least you can agree. It's a model. Everything is a model. You can say, I don't like this model, I don't like this idea, but then you have to write me an email and explain what is wrong with that idea. Okay? I would appreciate that. Okay. The next question, if we have now detected the smallest thinkable thing, entity, how can our brain know that that is an entity? And for that, and that is also very interesting, for that we use the ability of our brain to make a delimitation. Delimitation means I'm able to see with my eyes. My eyes are not seeing, my eyes sending signals to my brain. So my brain is analyzing this picture, and one of you immediately recognized using that boundaries, oh, this could be the 101, the Tower 101. So everything what is delimitable is an entity. That's also very logic, because if it's not delimitable, I cannot see it. And this is also, by the way, what artificial intelligent systems are doing. They can do that very well using artificial neural networks. They can delimit objects from the rest of the picture much better than we can, because we can equip them with billions of neurons. And you know that is used, for example, in the medicine area, detecting cancer on pictures. So the machine is much more better doing the delimitable tasks than we are. So again, the machine is superhuman. Only in detecting or in finding boundaries, delimiting things and giving that things a name. Yeah, giving a name is another issue. I come to that. So this is why we can talk about entities and, oops, what's that? What happened here? Can you see that?
101.
Yeah, there is a 101. But this is not realistic, isn't it? The tower hasn't a 101 on the end. But what is that 101?
Like an association towards the building.
Yes, it's the name for the building. We already talked about that. So we are able, and this is interesting, and every linguistic culture in this world, every nation, every culture is doing that. We assign names to entities. Why do we do that? Can you explain that? What you are doing all the time?
Simplicity.
Pardon?
Simplicity.
Simplicity, yes. Yes. And to be able to talk efficiently and simple. Otherwise, so this is the name of this entity, and this is an association between this name and this entity, because these numbers are not stamped on this tower, only on my picture. And funny, you talked about simplicity. Sometimes, perhaps you did that in your life, we try to explain things without using name for physical entities. So I can say, when I point out this tower, oh, this is the tower in a big city, in a country that is an island with beautiful people, in an ocean close to a big land mass, and a country with thousands of other islands. So hopefully everybody understood what tower I mean. Probably not. But this is the tower I mean. And try to explain that to you without using any name dedicated or assigned to a physical entity. Because in this sentence I used a lot of names. I used the name tower. Tower is a name too. For what?
All buildings.
For all buildings? For a tall building, yes. But not for a physical entity. There is no tower on this planet. There is a word tower we use when we want to talk about tall buildings. So do you see the difference? So tower is an abstract word. And if we wouldn't use that, we couldn't talk at all. So we need words for ideas. Tower, when I call the name tower, your brain is recalling that mental entity in your brain. Because you try to follow me, and you have an idea about what a tower is, and that is also interesting and important. Not every person in this room has the same idea about what a tower is. So we all make representation of the world by ourselves. And this is also important to know. Okay, so we now know the smallest thinkable thing. It's an entity, and the question is, which different kind of entities exist? So you are the persons looking at this picture, and I already talked about everybody has a representation of that tower in his mind. You can wake up in this night and you can think of the 101 of this tower. You can recall this thought if you like. And I use different colors because everyone has a little bit of different meaning about how this tower looks like, and everybody has a different representation of that tower. So at the end of the end of this story is that there is a tower, and this tower is a physical entity. That's for sure. There is another funny story about philosophers. There is a talk between philosophers about, is this column here real or not? This is a physical column, right? And how can you prove that? Vibration. There is no real proof. So at the end of the day, one philosopher said to the other, if you are standing in front of this cement column and you ask yourself, is this column real or not? You don't have a philosophical problem, you have a psychology problem. So you cannot answer that. And you don't must answer that. Because for all of us it's clear this column is here. We don't have to discuss about that. It's Zeitverschwendung. Time. What is Zeitverschwendung in English? Pardon? Zeitverschwendung?
Zeit like brain. Yes, my English is
Nicht so gut, okay. We make the next lecture. Yeah, okay, so we have one time, we have physical entities, and what I want to tell you, in our brain we only have mental entities. Beside the brain itself, made of neurons, made of chemical substances, made of whatever. But we have these mental entities. So we have two different types of entities, and interesting again, mental entities only exist in systems we call brains. You will not find a mental entity outside a brain. Or did anyone meet a mental entity outside the brain? I never met an entity outside the brain. So I have the idea that all of you here in this classroom now have a mental entity which represents the 101 tower, that's for sure. Hopefully you have a mental entity now which represents the smallest thinkable thought, this entity. So I know a lot of what's in your brain and what mental entities are in your brain. But these are only in your brain. And even when I talk to you, I cannot, and this is also very interesting, I cannot bring this mental entity out of my brain. It cannot be stolen and nothing. It's always in my brain, and I only can talk about my thoughts and my ideas. I can make a copy of what I'm thinking to tell it to you, hopefully in a good English. Probably not, but that's the question of the mother tongue. I have to translate my thoughts in a language which I think you can understand. And then I make a copy of my mental entities in your brain. This is mental work. This is learning. And this is teaching. Transferring pictures, transferring mental entities. I cannot transfer that mental entity, but I can copy that mental entity in other brains. And that's it. And these mental entities, that is also very interesting, are always representations of something. So what we think is always a representation of another entity. So it's important to understand also the next questions. If we look at this one guy having one mental entity in this representing this physical entity, we didn't talk about this 101 name. So what is this name? Where is this name? Is that a mental entity or is that a physical entity? What do you think? Combination? Something between? So you would agree this 101 is not a physical entity, right? And if it would be a mental entity, this 101 would be inside the brain. So it's not a mental entity and it's not a physical entity. It's an entity, you know a lot of types of these entities because you are watching a lot of videos. This is a virtual entity. Okay? We talked about iRobot. Some of you know iRobot is a name for a humanoid, or the name of this iRobot is Sony. Sony is the name of a humanoid robot. A lot of you know this name and this robot, but this robot is not existent. It's nowhere. It was never existent and probably it will never be existent. And this 101 is also not existent. It doesn't exist. The tower exists, but not the name. The name is virtual. And we use that to be able to take items, entities, and to talk in an efficient way to each other. So this is a definition done by human beings. And of course, we have a representation of that name. I have a representation of 101 in my mind, otherwise I even wouldn't be able to talk 101. And at the end of the day, a name is a motion pattern. You have to learn to speak names. Who want to speak my last name, Grebner? Yes? Oh, very good pronounced. So sometimes for a lot of people it's hard to pronounce Grebner. Yes. So you try to learn speaking names. You try to train your vocal cords to be able to speak that accurate. So a name is a motion pattern of your vocal cords. Also. So this is interesting, and because that gives a lot of insights how to deal with names and so on and so on. But this is a virtual entity, and we have a representation of that virtual entity, like I already just told, in our mind. So there is a mental entity representing this virtual entity which doesn't exist. It's not so easy to understand. And we have already talked about this association between this mental entity and that mental entity. And that looks a little bit similar to computer programs. And it's incredible, we can think of things that do not exist at all. And that's fantastic. And we call them virtual entities. I will immediately create a representation of a virtual entity in your brain right now. If you look at this picture, everybody is looking at this picture. A lot of people are looking into their mobiles. Don't look in your mobile, look at this picture, otherwise you would not be able to be part of this story now. He's leaving the room. Toilet, okay. Should we wait and make a break?
It's good if you have 10 minutes break or 5-minute break so they can cook.
Okay, yeah, toilet. 5 minutes, toilet break for everyone, so everyone can be part of this next experiment.